Hey everyone, this is Wartime Workshop, and this is a model BC-654 transmitter and receiver, the main component of U.S. Army radio set SCR-284. This 45-pound absolute unit of a radio was made by Crosley Corporation during World War II. I'm interested in wartime technology, so I got this radio planning to clean it up and get it working again. I'm going to document that process in videos on this channel. My hope is that someone else finds this interesting, entertaining, or educational. If that sounds like you, I hope you'll stick around and consider subscribing. This will be the first in a multi-part series on the BC-654. Today, I'll be disassembling the radio, assessing the construction and design, and replacing some missing components. The BC-654 was technically considered portable, able to be mounted in a vehicle or carried on foot. But it was still an old-fashioned vacuum tube radio. In addition to the 45-pound main unit, you needed to carry around another 60 pounds of accessories for it to be of any use. The radio itself contains delicate tubes, intricate wiring, and a surprising number of moving parts. Multiple sources quote soldiers as saying that these devices were exceedingly cumbersome on the battlefield, and I can see why. If you needed to transmit, and you weren't in a vehicle, you often had to power the radio using a hand crank generator that looks a lot like a piece of exercise equipment. I would imagine that factor becoming especially significant if you just rucked the equivalent of a mini fridge on your back for several miles. In exchange for all the inconvenience, you got a complete portable radio station, comprising a high-frequency receiver in the top part of the case, a transmitter on the same band in the bottom, and a built-in antenna tuner. The frequency coverage overlaps conveniently with amateur or ham radio bands, so I'll be able to legally transmit once my unit is working. As per the typical traditions of ham radio, I expect about 90% of the conversations I have using this thing to be discussions about the radio I'm using. Seriously though, I think the radios from this period are fascinating. Despite being electronic products at heart, they're highly mechanical. Much of the design is motivated by the need to fit numerous, large, delicate components into a portable container. Now that I've said that, you'll probably want to see the inside. To disassemble the BC-654, you first remove the lid from the case. Then you loosen thumb screws around the front panel, and the radio can be pulled out the front of its enclosure. The enclosure, by the way, is great. It's just a metal box, but inside there's a beautiful schematic of the radio. There are also military markings, including dated order numbers. Flipping around to the back of the assembly, the receiver is dominated by a huge variable capacitor, with a geared mechanism driving it. In the transmitter section, there are several large tubes and capacitors, plus all the hardware for the antenna tuner subsystem. A fair amount of thought went into making the innards of the radio accessible. A really cool example of that is the linkage on the side. It's a toggle arm that allows you to pivot the top receiver section forward and access the transmitter section from above. So, this isn't just a rigid frame, but an articulated assembly, just to make maintenance easier. I nerded out as soon as I got a look at this thing. Physically, this radio is in great condition, only requiring a little bit of cleanup. A few mechanical components are missing, and I'll need to install a power supply. The electronics inside are also likely to require some serious repair. It's common for the paper capacitors in these radios to stop working with age, requiring replacement. Now that I'm inside, I'm noticing that this radio has a particularly heavy coat of moisture and fungus-proofing lacquer, or MFP, with a labeled coating date of July 1945. It looks like at least some of the tubes have been replaced since the coating, potentially by another ham or collector. That may bode well for getting it working. It's also possible that the coating has protected the notoriously bad paper-molded capacitors from moisture. But 75 years is a long time, and I'm not holding my breath. We'll get into the details of the capacitor issue in a future video. Although there are several missing parts, I was able to steal replacements from another radio that's in worse condition. The first part that's clearly missing is the receiver tuning knob. This piece sits on top of a felt washer and attaches to the receiver tuner shaft with a set screw. The tuning gears take a fair amount of torque to rotate, so the crank-style handle is actually very helpful. The other missing component is less obvious, until you try to install a power supply. There are two options for the internal power supply of the BC654. One is a battery pack, the other is a power converter module called a PE104. Whichever of these is used, it needs to be mounted in the top right corner of the radio, so it can plug into this wiring harness. Normally, there's a small sheet metal shelf that holds the power supply, but that assembly is missing from this unit. Apparently, it's very common for this shelf to be missing, so I was lucky to be able to find a replacement. The installation of the shelf is pretty easy. It's held in place by a few machine screws, and the wiring harness wraps around some support pegs on the side. I think I spent more time making sure I had all the fasteners in the right place than I actually spent installing the shelf. As I mentioned, the power supply shelf can host either a battery pack or an electronic power converter. These devices both produce all the voltages required by the receiver and several of the voltages for the transmitter. I do have a PE104 converter unit, but it makes me a little nervous. It uses a really neat but really finicky electromechanical circuit to step up a low-voltage source. I'm afraid that the output voltages could be unstable if I make any mistakes during my restoration. Some of these voltages are critical. For instance, the filament supply, nominally 1.5 volts, can destroy all the tubes in the radio if it goes too high. Since I really don't feel like buying a whole new set of tubes, I'm going to set the PE104 aside for now and attempt to build a working replica BA43 battery in its place. This will give me stable, consistent voltages that I can fully control. As a bonus, the BA43 battery can be used with any transmitter voltage source. The transmitter requires a separate high-voltage supply of 500 volts, which can come from either a hand-crank generator or a vehicle dynamotor. I have a dynamotor, and I'm working on collecting the parts for the generator, so I'd like to try them both. The Signal Corps manual advises not to use the power converter with the crank generator, except in emergencies. So, if I used the PE104 converter, I'd have to stick to the dynamotor. The battery leaves me with either option. Creating the replica battery pack will allow me to test the receiver section, so this will probably be my task for part 2. I've got a few ideas for how to do this, and I think it will make for an interesting project, so stay tuned. Before I end this video, I need to mention one more thing. I'm far from the first to work on one of these radios. Sets like this, and other sets from World War II, have been operated by hams for as long as they've been available. I really couldn't get anywhere on this project if it weren't for the fantastic resources already available online. I've included several links in the description to resources that taught me what I needed to know for this project. These sites deserve thanks and patronage from anybody who is interested in this sort of work, and this video wouldn't be possible without them. With that, all I have left to say is I hope you'll be back for part 2. And, of course, thanks for watching.